Okay, so we're talking about equivalent ratios now, which is similar concept to the simplifying, but it's a slightly different. Okay, so what do we got? All right, so if you have a ratio, let's say 1:7. Okay, now let's say you, I don't know, you got paint is to terps. Okay, so that's how you're supposed to dilute something. Okay, you would get the same kind of mix if you went 2:14. Okay, whether it's 2 cups, 14 cups, 2 milliliters, 14 milliliters, 2 handfuls to 14 handfuls. It doesn't matter what the units are, so long as they're the same. But if I've got 1:7, paint is to terps, that's how I'm supposed to, water down this particular paint. I went from there to there by multiplying by 2. Okay? So the big idea is, if I use 2:14, I would have the same quality or type of mixture. Okay? Just more of it. Okay? All I'm changing is how much I've got, not the type of mixture. Okay, so from an industry point of view, that's the idea of equivalent ratios. If I had a gearing ratio, let's say I had gear 1 is to gear 2, and it was, 3:10. Okay, that's my gearing ratio, and so step up gears. So if I had 30:100, I'd have the same. I mean, having three teeth on a gear is not really possible, but 30:100 multiplying by 10, that would work. You can imagine a gear with 30 teeth and a gear with 100 teeth. It's the same ratio. Similarly, 60:200 would do the same thing. Okay, because what I did from there is I just multiplied by 2. Okay, so that would work. They would have the same gearing ratio as that if I had 60:200. Same result. It's doing the same job, okay, even though the numbers are different. So that's the idea of equivalent ratios. They do exactly the same job as the simplified one. You just got more of it, okay? Righto, so let's look at how the maths works. So this is on page 10. Page 10 of your workbook. Let's just do these 4 across here, okay? So I've got 2:9. So what is that? Something is to 18. So here's basically what you've got to look at. How did I go from 9 to 18? Well, I times that by 2. Okay, so if I times there by 2, I've got to times that one by 2, because you do the same thing to both numbers, so that's 4. Okay, so if this was a dilution ratio, for automotive paint or something, if it's supposed to be 2:9 with let's say cups, 2 cups to 9 cups, well, if I went 4 cups to 18 cups, it'd be exactly the same type of mixture. Okay, just more of it. So look at this one here. How did I go from 5 to 25? Well, I multiplied by 5. And if you're not sure, just go, well, how do we go back from there? 25 divided by 5 is 5. So I've multiplied by 5 going in that direction. So I've got to multiply by 5 over here as well, because that's the rules. You do the same thing to both sides. So that's 15. Now, this one here with a 3-barreled one, it's the same concept. I've got to do the same thing to each number. So how did I go from 5 to 30? Well, I times by 6. So I've got to multiply that one by 6 and that one by 6. Okay, 1 times 6 is 6, that's easy. 6 8s are 48, bang, that's that one. Lastly, this one here. How do I go from 3 to 9? I times it by 3. So I've got to do the same for all of these. 4 times 3 is 12. 5 times 3 is 15. Now, interestingly enough, 3:4:5. Builders. Anyone who's supposed to be a chippy, you got to know this. If I have a triangle that I've got 3 meters that way, 4 meters that way, and 5 meters that way, 3, 4, 5, that angle right there will always, every single time, be a right angle. This is how they actually establish right angles for footings. Okay? Does it have to be 3, 4, 5? No. If I went 6 is to 8 is to 10, if I measured out 6 meters and then 8 meters and then made sure across there was 10 meters, then that would be a right angle as well, because it's equivalent ratios. Okay? All right. That'll do it. Go and get working.